I'm Don Pettit, and I'm on the International Space Station. I'm one of the lucky guys that get to fly in space. I use my off-duty time to investigate scientific curiosities of my own design. So what you are going to see is a series of my own investigations that I do simply because I am here and I can, and these things tickle my imagination and enrich my mind, and I'm hoping that they will do the same for you.
Okay, I'm working once again with stretched thin films of water. And you make these on a loop, not unlike what you'd make a soap film with on Earth, but these are made with pure water, with no surfactant. And as far as I know, these cannot be made in the presence of significant gravitational forces. They break. And once you make these films, there's a bunch of delightful things you can do with them.
I'm going to oscillate a little bit. Look at that. Really some wild things you can do. And that's because these films are thick compared to a soap film. And there's more mass in the film, and you can get this inertial mass moving in a weightless environment. So, oh, look at that. You can even spall off little drops. Let's see if I can do that. And then you can capture them back again. Oh, look at that. I spalled off a drop, and now I'm going to capture it. There. Okay. Spall off a drop. Oh, 2 drops, and I'm going to capture the drop. I'm going to capture the drop. Oh, look at that. It bounced off. There, we captured it. So
you can use them as sort of a liquid drum head to shoot other water droplets at and look at the behavior. Here's a Teflon needle hooked up to a syringe, and I'm squirting water at one of these films, and some of the droplets bounce off. Some of the droplets get assimilated in the film, and some of the droplets actually go through the film and jet out the other side. So there's a lot of really neat physics going on here. I'm still in the process of trying to sort it all out. And then I'm putting tracer particles in these, and these are white ones. They're white tracer particles. Going to put a couple drops of these in, and then get some convection going here, which stirs these particles around, and then wait for all the fluid motion to stop. So here we have a stationary pattern, and I'm taking the soldering iron that we have on space station, and I'm putting that tip close to the wire frame, and it adds a heat source. And that heat source changes the surface tension next to the wire, and the surface tension forces then get in a tug of war, and they incite this convection, the fluid motion that you are seeing here. And this is known as Marangoni convection. Now notice the direction of the convection here. It's going from the center of the film to the edge of the wire where the heat source is. And we will see something really neat here. It looks just like the other one, but it's significantly different. The last setup, the water film was slightly thicker in the center than at the edge of the wire. So the films were convex, and the fluid motion went from the center of the film to the edge of the wire. So here I have a film that is concave, so it's thinner in the center and thicker at the edges. The convection is indeed reversed. So here we see an example of Marangoni convection where you have a convexed fluid surface and the fluid goes from the heat source away. When we had a convex surface, it went towards the heat source. Now watch this. This was a really interesting example. Look at the violent nature of that convection. And now we're going to actually touch the tip of the soldering iron to the fluid film itself. And again, look at the intensity of the convection that results from that.